Okay, today we will start with the topic of the course, which is the fundamentals of traffic flow, and this is taken from the highway engineering textbook. Okay, the Garber and Hoyle textbook uh, from chapter 6. Okay, so there's a term which is called as traffic flow theory. Okay, theory means what? Theory means that something which explains the behavior. Right? A theory is something which explains the behavior, the physical phenomena, the behavior of particles, and so on. Okay. So, for example, the Einstein has theory of relativity. Okay. So that theory explains how things behave when they are in motion, or how you feel when the things are when you are moving. How do you feel about other things? So that theory explains this phenomena. Okay. So that is theory of relativity. Similarly, we have traffic flow theory. So traffic flow theory again explains something, right? So it explains what? Traffic flow. Yeah, how traffic is moving, okay, or how it is supposed to move. So in this theory, they have developed relationships. You can call them relationships. You can call them models or equations or formulas. Okay, so they have developed equations and formulas for traffic flow. Okay, so traffic flow theory explains the flow of traffic with the help of these equations. When the flow is this much, the speed is supposed to be this much. There are three main parameters of traffic flow theory. They are flow, density, and speed. Traffic flow theory is based upon three main parameters: flow, density, and speed. Okay, and they are interlinked with each other. So when the flow changes, it has an effect on speed and it has an effect on density. When density changes, it has an effect on other two, and so on. Okay. Okay. Why do we need traffic flow theory? Because as traffic engineers, we need to plan for the highways, we need to design them, and we need to see if the design is effective or not. The design is fit for the purpose or not. What are we trying to achieve from the design? Is it fulfilling that objective or not? Okay. So to do the planning, to do the design, to monitor the effectiveness of the design, we need to understand how traffic moves. Okay, if you don't know how traffic moves, then you cannot do the planning and design and find out the effectiveness of the design. Some of the examples are given here which are related to these things. For example, you have a left turn lane. You have a left turn lane at an intersection. Now, how long should be that lane? You may have seen if the lane is not long enough, then you have cars which come from that lane and then they go in the other lane. So the lane is good for 10 cars, but now we have 15 cars. So the other 5 cars are blocking the other direction, the other movement. So the person who was designing this intersection or designing this left turn lane, he should have known how many cars to be expected. Okay, and this is again function of flow and speed and density. How many cars you can expect in this left turn lane? For example, for a 10-second signal. So signal is red for 10 seconds. How many cars can I expect in these 10 seconds? This is a function of flow, density, and speed. The average delay, you want to find out the average delay of the intersection or a ramp area where people are coming on the freeway from the ramp. Okay, so Now, the first one was a design example, right? You design how long should be the length. This one is effectiveness after design. Okay, if the design is effective or not. So if the delay is more, design is less effective, and vice versa. But how do I calculate the delay? Again, I need some model which can explain how cars will come, at what rate they will come, how much they have to stop, for how much time they have to stop, and so on. You have a ramp, and on that ramp you have installed a stop sign now, or you have installed a signal now. Okay, so after installing the signal, what will be the effect on the freeway and then the ramp? Okay, so again, to find out this effect, you need the help of traffic flow theory. Okay, so traffic flow theory is used, or it gives you the interrelationship between different traffic parameters, as I already mentioned. Okay, and then you can use them to estimate the effect of traffic on the network. If this much is the traffic, what will be the effect? And you can also see the effect of traffic flow on other external parameters. For example, accidents, crashes. Okay, travel time of the road and travel time of the drivers. Air pollution, gasoline consumption, gas consumption. Okay, so traffic flow theory gives you the main parameters: flow, density, and speed. Using these main parameters, you can see the effect on other parameters as well. These parameters are not part of traffic flow theory. Crashes, travel time, air pollution, consumption. They are not part of traffic flow theory. But if you know the parameters of traffic flow, then you can calculate these things as well. Okay, so traffic flow theory has more applications. Okay, a very important graph in traffic flow theory is the time-space diagram, which you see on the slide here. So we have space or distance on the y-axis, and we have time on the x-axis. Okay, so when you observe the movement of a car, observe the movement of a vehicle, so you can observe how much distance it is passing and in how much time. Distance and time. So after every few minutes, you know the distance and you know the time. So you have the two coordinates, right? You know the x and y. So using those x and y, you can plot them over here. So these lines are basically representing the vehicles. So the first line is for vehicle number 1, this for vehicle number 2 and 3 and so on. Clear? So we can see here there are 6 vehicles which were observed, and for each vehicle we have established a line. Okay. Now if I take the slope of a line at any point, it will give me what? Speed. Slope of the line will give me speed, right? Distance upon time is speed. So we have y upon x, distance upon time. So you can calculate the slope. For example, for vehicle number 1, you come to this location and I want to know the speed of the vehicle at this location. So at this location I will find out the slope of the line. This will give me the speed. Okay. Now, if you look at line number 3, vehicle number 3, what is happening with the speed? It is changing, right? It is changing. Okay. So you can see the changes in speed as well. You can see the changes in speed as well. What is this representing? Constant speed. Constant speed? Yes, constant. Okay. How much? How much is distance?
Zero.
Zero.
Speed.
There is no distance, right?
Yeah.
So the speed is
Zero.
0. Speed 0 means the vehicle is
Stop.
stopped. Now if you take what they have mentioned here is, I think, T, how much is it? T3 and T3 dash. So if I take the difference of these two timings, then I know for how much time the vehicle was stopped. Clear? You can find out the time for which the vehicle was stopped. Okay. Now you see here, we have a parameter D34. Okay, D34. This is what? What is D34?
Distance between
Distance between two vehicles at this time. Got it? Okay. So this one is called as spacing. This is what we call as spacing. So if you take at any point of time, you take the distance between two vehicles, consecutive vehicles, okay? So I cannot take between 1 and 4 because there is 2 and 3 between them, right? So you cannot jump vehicles. So I can take it between 3 and 4, and 4 and 5, and 5 and 6, between two consecutive vehicles. And we call it what? Spacing. Okay. Then you see H34 as well, right? H34. What is it? Time between two vehicles for the same distance, right? For the same point in space. So at this point in space, vehicle 3 is here and vehicle 4 will pass at this time. Okay? So this is a time between two vehicles in crossing a common point. And we call it what? Headway. This is what we call as headway. Okay? So D34 was what? Spacing. And H34 is what? Headway. So what are the things you can find out from the time space diagram? Tell me. From this diagram, how many things have we discussed now? Slope means speed. Okay, what else?
Distance.
We call distance what?
Spacing.
Spacing. Headway. Okay, and what else? There was something else. Yeah. Where did the vehicle stop and for how long the vehicle stopped? And obviously, if you want to find out the total time or the average speed, you can do this. Okay, you can take total distance, total time, you will have the average speed. Okay. Okay, so I told you primary elements of traffic flow are 3. We have flow, we have density, and we have speed. Flow is represented with Q, density is represented with K, and speed is represented with U. Okay, so flow is the equivalent hourly rate at which the vehicles pass over a point during a period less than 1 hour. Okay, so you take a value of, for example, for 15 minutes, okay, and then you convert it to 1 hour. Okay, so this is how they are defining flow or rate of flow here. Okay, so for example, you observe number of vehicles for T minutes, I think. No, T seconds. T seconds. Okay, so T is the number of seconds for which you made the observation. Okay, so if you made the observation for 15 minutes, then 15 into 60, right? For number of seconds. And then you convert it to, and how many vehicles you observed in T seconds? N. So how do you convert it to rate of flow or flow? Like this. N, number of vehicles, divide by number of seconds you observe, multiply by 3600, which is what? For 1 hour, right? For 1 hour. Clear? Clear? Any questions? Okay. So this is how you get the rate of flow. How you get the rate of flow. So it's always what? Vehicles per hour. It's always vehicles per hour. Now remember, we are talking about traffic flow theory. Okay. So everything is in the perspective of traffic flow theory. In traffic, we mentioned that we can have volume vehicles per day as well, but that is not used for traffic flow. Okay, so here we are only talking about terms which we will use in traffic flow theory. Then we have density. Another name for density is concentration. Concentration or density means the same thing. What is it? It's the number of vehicles over a unit length of the highway at a particular instant of time. Right now. So it's an instantaneous value. Okay? It's a time related value. So density now will change next second, right? Because the vehicles are moving. Okay? So you may have 50 vehicles in unit length of the highway right now, but these 50 vehicles are constantly moving. So this is 50 right now. If half a second passes, some of these 50 will move forward and some others will enter. So the density or the concentration can change for every millisecond of time. Got it? Okay. So density is time related and it keeps on changing. Usually the length is 1 mile. Okay. Or it can be 1 kilometer as well. So number of vehicles per mile or number of vehicles per kilometer. Can I have vehicles per meter or vehicles per feet? Why not?
Vehicle is larger than meter.
Yeah. Okay. So you will always have fractional values. So to avoid that, we don't take small units for length here. Then we have speed. Speed, you know speed, right? Everybody knows speed. Huh? For the sake of traffic flow theory, we measure the speed of the vehicles in miles per hour, kilometers per hour. You can also measure it in feet per second for the sake of keeping the same units. There is no problem with that. Okay. So for example, you have number of vehicles passing a point on a highway segment and that was counted to be 500 during an interval of 15 minutes. Find out the equivalent hourly rate for this segment. So they counted 500 vehicles in 15 minutes. How many in 1 hour? What is the rate of flow for 1 hour? Tell me. So I need the Q value.
500 times 60 power
500 times
60
60
power 15.
How much is it? 2000?
We can multiply 500 and
Huh?
500 multiply by
Yes, no problem. Okay. Now this Q value of 2000. This is because the flow in 15 minutes was 500, right? So the actual volume of 1 hour may not be 2000. Somebody took the flow for 15 minutes. According to this, the flow in the whole hour could be 2000. But somebody, let's say somebody goes there and he actually stays there for 1 hour for counting the number of vehicles. He may observe 2000 or he may observe more or less, right? Okay. Now if somebody stays there for half an hour, so he stayed there for 15 minutes, he gave you a value 500. If he stays for another 15 minutes, will you observe the same value?
Maybe yes.
Yeah. So from that value, can you recalculate the flow rate?
Yeah.
From the new 15 minutes value? Can you calculate the flow rate, right? Okay. What will be the units of that flow rate? Meters per? Per hour, right? This one is also per hour. And that one is also per hour. Are you talking about the same hour? Are you talking about the same hour? It's the same hour, right? It's the same hour, but different time periods of the same hour. Right? The flow rate in different time periods of the same hour. So the rate of flow can change within the hour as well. Although the units are per hour. Although the units are per hour. But the flow behind that is changing. That's why the per hour rate is also changing. Got it? So you can have multiple values of per hour from the flow rate. I think we already covered it. Any comment you want to give about the speed of the vehicles in this diagram? Anything you observed in this diagram about the speed of the vehicles?
Seems at the end they have the same speed and
Okay. So in the end they have the same speeds. Okay, what else? Anything else? Hmm.
it's not to start from zero.
That time will not start from 0.
There are change in speed, like vehicle 4 speed changes at different time.
For vehicle 4, the speed changes at different times. For vehicle 3 as well, right?
Yeah.
For other vehicles, the speed is constant. And the reason for the time not starting from 0, it could be that they are measuring 0 from their own reference. Okay, so 0 doesn't mean the 0 of the trip. 0 could mean 10 o'clock. Okay, so these vehicles started at 10 o'clock, but maybe this one started at 10:05 or something like this. Okay, so you can see some of the vehicles have constant speeds, 4 of them. The middle 2, their speed is changing, and you can see which vehicle had a problem in which segment. So for example, vehicle 3 had a problem in this segment where it goes horizontal, and you can see vehicle 4 had a problem in, is it the same segment? Seems like it. Okay, so you can identify the problem segment as well, where the vehicle's speed normally changes. Okay, and you can compare between the slopes of the line, and you can know which vehicle is faster or slower. Okay, so you can look at the slopes and you can see which slope is higher So it seems like vehicle number 1 has steeper slope, that means it has more speed, and so on and so forth. Okay, at time 6 seconds, what is the space headway, meaning the spacing? Space headway means the spacing. So at time 6 seconds, what is the space headway between vehicles 3 and 4? So how do I find out the spacing between vehicles 3 and 4 at time 6 seconds? What do I do?
Take bond vertical.
Yes. So I go at time 6 seconds. Okay. I draw a vertical line. Okay. Line 3 and 4, right? Vehicle 3 and 4.
516.
Yeah. So this one is 560. This one is almost, what happened? This one is almost 240. Okay. So
Greater than
it will,
240.
sorry,
Greater than 240.
greater than 240. Yeah. 240 is here. So between 240 and 320, how much?
280.
280. So 280 minus 560. How much? 280, right? How much?
280.
Okay. Then speed of vehicle 3 at time 3 seconds. Where is vehicle 3? This is vehicle 3. What is the speed of vehicle 3 at time 3 seconds?
0.
0, because it goes horizontal, right? I think it would be in feet. This is feet, right? Okay. Speed of vehicle 1. What should I do?
Take 2 more. First one. Take
Which 2 points? Huh?
So,
Yeah.
Slow.
So which 2 points? Any 2 points. Can I do the same for other vehicles?
No.
Take any 2 points? Why not?
because the slope is changing.
The slope is changing. For vehicle 1, there is no change in slope. You can take total distance upon total time, or you can take between any 2 points as well. So you can take between 800 and 720 and look at the time. Okay. So 5 seconds and 800 feet. And then I have 6 seconds, 840 feet. So how much will it be? So I have 840 minus 800 upon 1. Forty feet per second, right? Clear? Any question? Okay, then we have the types of mean speeds. We have two types of mean speeds. One is called as time mean speed, the other one is called as space mean speed. So time mean speed is the arithmetic mean, the simple mean. Arithmetic means the simple mean total upon number, okay, of the speed of vehicles which are passing a point during a given interval of time. So you stand over a point, you should have a speed gun or something like this with you, a speed measuring device, and that device will give you the speed of the vehicles over a point, and then in the end you take the simple average, the simple mean. Summation of speed upon number. Clear? Okay. What do we call it? Time speed. Okay. And then we have the space mean speed. Space mean speed is the harmonic mean. What is the harmonic mean? When the mean is done like this. Okay. This expression is called as the harmonic mean. So you have the number on the top divided by summation of inverse of the values. Okay, this is called as harmonic mean. You have the simple mean, which is the time speed. Then you have the harmonic mean, which is the space mean speed. So you have again the same thing. You are over a point. You have a device. The device gives you a number of speeds for the vehicles, and in the end you can do the harmonic mean. There is another way for finding out the space mean speed as well, which is using the length of the road. So you have the length of the highway and you measure the travel time of the vehicles to pass over this length. Then you don't have to do harmonic mean. You can calculate the space mean speed using this. Okay. So N is the number of vehicles you observed. L is the length of the road for which you are measuring the time. And Ti is the travel time of each vehicle. Clear? Okay. Time mean speed is a simple mean of speed for, which is taken over a point. There is no other way. Okay. For space mean speed, you can find out in two ways. You can again take the speed of cars or vehicles over a point and do the harmonic mean and upon summation of inverse. Or you can have a length of the road and you can use the second equation. You can have the length of the road, observe the travel time instead of the speed for this length, and you can use the second expression to find out the space mean speed. Clear? Okay. Okay. At a particular time on a highway, the speed of 3 vehicles is this. They have given this in miles per hour and kilometers per hour. Find out the time mean speed and the space mean speed. Very simple. For time mean speed, I will do what? Yes, tell me. For the time mean speed, simple mean. You take the simple mean. How much is it?
43.67.
In what? Miles per hour? Okay. For space mean speed, we will do what? Which mean do we take? Yeah, for space mean speed, I will take harmonic mean. Okay, so it will be 3 upon 1 by 48.2, 1 by 44.6, 1 by okay, how much is this? $43.2. Okay. What's the next one here? If the space mean speed for 3 vehicles on a highway segment is this much, and the individual speeds for 2 vehicles is this and this, what is the speed of the third vehicle? So space mean speed is given, US is given, and speed of the 2 vehicles is given, 45 and 40. So you know US and you know the 2 speeds. You have to find out the third one. Okay, don't use this speed, these speeds. Okay, so instead of 48.2 you will have 45, and instead of 44.6 you will have 40.4. Okay, so what is the speed of the third vehicle? Tell me. I'll call it U3. Four, 8, 4, 1. Okay, any questions? Clear? Okay, I've already mentioned this time headway or just headway, meaning the time between what? How do we define headway?
Time to
From
Two vehicles for what?
for one distance of same distance.
Same point of time or same point in space. Okay, so the first vehicle passes. After 10 seconds, the next vehicle passes the same point. This is their headway. And a spacing, they call it a space headway, or spacing means the same thing, which is the distance between two vehicles at a given point of time. Okay. So the spacing can be, or the headway can be for any point of the vehicle, but for the sake of simplicity, they are saying that these parameters are measured from the front of the vehicle, both of them. Okay, so for example, you start measuring the distance from the front of the first vehicle. So where will you end? The front of the next one. Okay? Clear? So when you are driving, the instructor asks you to have some space between you and the other car, right? Is this spacing? The distance he's asking for, is this spacing? No, because that is from the back to the front. So you cannot call it spacing. So the spacing includes what?
Same reference.
Same reference, but then it also includes the length of the vehicle is included, right? So you start measuring from the front, the whole length of the vehicle, and then the distance, and then the next vehicle, right? So length of the vehicle is included in the spacing or headway. Both of them are measured from the front. Both of them are measured from the front. So if you want to know the time interval between two vehicles, again, you will start your watch from the front of the first vehicle, and you will record the time to the front of the next vehicle. Clear? And how you can see it in the time space diagram, I've already shown it and discussed it with you. Okay. This figure shows vehicles which are traveling at constant speed on two-lane highway between sections X and Y. Where is X and Y? Okay, the boundaries X and Y. The positions of the vehicles are given, their speeds are mentioned at a given instant of time. So when the vehicles are moving at a particular time, they took the picture of the highway and they fixed the distance. They found the distance. Okay, for each vehicle, now they know the distance. And observer located point X, observe 4 vehicles passing point X during a time of t seconds. So these 4 vehicles, they passed point X in t seconds. Okay, in t seconds. So from vehicle A to vehicle D, from vehicle A to vehicle D, they passed in how many seconds? T seconds. Point X. The velocities are given, same. Okay. Calculate the flow, density, time minute speed, and the space minute speed for these things. Okay. Flow. What was flow? Number of vehicles? In 1 hour, right? In 1 hour. Is it 1 hour? No. So what were we doing? I need Q. There was an equation, right? For Q there is an equation. What was the equation? It was N
each, for each day,
Huh?
for 45.
Do we know T? Do we know T? Do you have value of T here? Look at the question. Do you have the value of T? We don't have, right? Huh? So, how? Tell me. We can do it, yes. We can do it. But in the book they did not do it. They kept it in terms of T. They kept it in terms of T. So how much is N? Tell me. N is how much?
4.
4. Okay. So 4 into 3600 upon T. Whatever the T is. How much? 4 into 3600. How much? This is what they have done in the book. They kept it in terms of T because T is unknown. Okay. Now what you were saying,
Convert speed.
because you know the speed of the vehicles and you know the distance between them,
Distance is in feet or meter.
it's in feet. It's in feet. Okay, but the problem with this approach is you are assuming when they crossed point X, their speed and distance was same. Okay, so here they are saying they took the picture of the highway when the vehicles are in this position. So if you make the assumption that, for example, between the speed of the vehicle is 45, this one is 45, this 40, this 30. So this is the same speed and the distance between these vehicles also same when they were crossing point X, which is an assumption. Okay, so if you make this assumption, then you can calculate how much time will be taken from vehicle A to vehicle D to cross point X, and then you can put it as T. Okay, but this is an assumption. Clear? In the book they did not do it. Okay, what else? They asked for flow, we have flow. What else they are asking for? Density. What was density? What is density?
In one distance.
Over distance, right? Number of vehicles over distance. Okay. So my distance is this whole thing between X and Y. What is my distance? Huh? 300 and total 300. Okay. So the density will be how many vehicles? 4. Okay. The next two things are easy, right? Time minus speed. You will take what? Simple average, simple mean, and for space mean speed, harmonic mean. So ut US. How much? 41. 40. And US. What are the units? Miles per hour, huh? Miles per hour, because the speed is in miles per hour. Any questions? Everything is clear?